Question 16, we're asked to write 640 million in standard form. Now all you have to worry about with standard form is seeing how many powers of 10 you can take from that number. So if we write the number out again, then we could look at this number in this particular way. We could say it's this number, which is 64 million times 10, or we could say it is 6,400,000 times 10 times 10, and so on. Now, if we kept on going, and I'll write this up here, we can just see how many zeros there are here, and that's 1, 2, 3, 4, 5, 6, 7. So that's like timesing by 10 7 times in a row, and I won't write them all out. And a quick way of writing that is to say 64 times 10 to the power of 7, 10 to the 7. But that wouldn't necessarily be the answer. The only other thing you've got to remember in standard form is that this beginning number here has got to be between 1 and 10. You wouldn't write 10 because that would have a power of 10 in it. So what do you think you'd write the 64 as? Well, if there's a power of 10 in it, because it's 6 tens and 4 units, then you could write that as 6.4 times 10. But you've already got this times 10 to the 7 left at the end. So how many powers of 10 do you have now? Well, here you have 1 power, 10 to the power 1 is just 10, and then you have not just this 1, but 7 more, so the answer would be 6.4 times 10 to the power 8. For part B, you've got to work out 3 times 10 to the power of 7 divided by, and this is why I'm writing it this way, divided by 6 times 10 to the power 4. Well, let's look at these ordinary numbers here first. If you did 3 divided by 6, what would you get? Well, hopefully you can see that would be a half. Then, if we look at the powers of 10, and we can write those as a separate fraction. The reason we can do that, by the way, is because if we've got a denominator which is multiplicative, i.e. something times something else, then we can separate the fractions off in this particular way. Okay, the same with the numerator, something times something, so we can just separate it out as 2 fractions. It means exactly the same thing. But what this will allow us to do is concentrate on, we've got the half, which is fine, so we can keep that there. But if we had 10 to the power of 7 divided by 10 to the power of 4, then I could write all of those out. But if you remember the rules of indices, if I have something to the power of 7 and that same something to the power of 4, then we can just take the powers away from each other and we'd be left with 10 to the power of 3. Now, is that going to be the answer? So a lot of you, if you use the calculator, might get something like 0.5 here times 10 to the 3. Your calculator could return that. It more than usually won't, but if we wanted to decimalize the half, then we'd get a 0.5 for sure. But would that be the answer? Well, in this case, you've got to do one more thing. Remember I said before that this beginning number should be between, so we'll call this n for the number, should be between 1 and 10. Now, it could be 1, but it can't be 10. Remember, if it was 10, then that's a power of 10. I.e., if I wrote the number 10 out, that's not standard form. It would be 1 times 10, which seems a bit silly, but that would be the standard form that you would write. So let's get back to this 0.5. Is that a number between 1 and 10? No, it certainly isn't. So we've got to make it a number between 1 and 10. And all you have to do here is to say if I use the actual significant figure here, 5, if I times that by 10, is that 0.5? No, I've got to divide it by 10. So I've got to make this power minus 1. Because if you're good at your powers, you'll realise that 10 cubed is 1,000. 10 squared is 100. 10 to the 1 is just 10, i.e. timesing by 10. 10 to the 0, well, anything to the 0 is 1. Notice how these are becoming 10 times smaller. So if you want to divide something by 10, the nice way of writing it is 10 to the minus 1, because that is 10 times smaller than 1, which is 1/10, i.e. making something 10 times smaller. So that would be exactly what we want to write 0.5 in standard form. 5 times 10 to the minus 1, i.e. you take 5 and you divide it by 10. But don't forget we had this 10 to the 3 waiting for us here. So to get the very final answer, we've got our beginning number, which is between 1 and 10, can't be 10. And then we use our rules of indices here. Our base is 10, yeah, that's common here. And then we add the powers, and negative 1 and 3 is 2. So I would say the answer would be 5 times 10 to the power of 2. So quite a long explanation, but I think it does it justice because there's quite a lot involved in standard form, and even if you think you know it really well, you can easily get caught out if you're not careful. Question 17. It says L1 and L2 are parallel lines, and it gives you that L1 is such that y equals 3x plus 2. Now, what does that mean? Well, it means its gradient is going up in the 3 times table, i.e. for every one you went along on the x, you'd go up by 3 times as much on the y, no matter where you started from. However, a convenient place to start sometimes is the intercept. So if you had a pair of axes drawn here, say x and y, and you started here at the intercept, which was say 2, that would mean if you went 1 unit along on the x, you would go up by 3 units here, and you'd end up on 5 on the y. That's all that means. And then you'd be able to plot that point, plot this point, and then you'd have your straight line. So that's just a little recap. It says L1 and L2 are parallel. So that would mean that L2 would have to share the same gradient. So it's going to be 3x plus something. I'll call that k. You can call it c, whatever you want. Now, it says that L2 passes through the point when x is 3 and y is 4. So that's really helpful because if you know the equation for L2, then you can study this coordinate here, and what you can gather from that is that if x was 3 and y was 4, you could find what the value of k is, and then you could complete your equation for L2 because you'd know everything about it. So I think that's what we should try. So we've got y is 4 and we've got x is 3. Don't forget 3x means 3 times x. So that gives us 4 equals 9 plus k. So if we take 9 from both sides, then we'd get negative 5 equals k, and that would mean then that L2 would be such that, and if you've not seen these two little dots before, that's more of an A-level thing. It just means if L2 is written in some way, then it's a quick mathematical way of saying L2 is such that. Okay, so those two dots mean those 3 words. So we'd have y equals 3x minus 5. That's all there is to that one. In this question 18, we firstly are presented with a box and whisker diagram, and we have to just simply write down the median. Now, if I enlarge this diagram a little bit, then I just want to quickly go over these parts here. So we have the lowest in the data. Here we have the highest in the data. Then we've got the lower quartile, which is up to the 25% part of the data. So we've got, I'll call that LQ, lower quartile. And I'll mark this up as the 25% part here. Then the 75% marker for the data would be the upper quartile. And then that only leaves us with the 50% part of the data. So if we ordered it all from the lowest to the highest and we went for the middle, that would be the 50% marker in the data, and that would be the median. And although it doesn't look halfway, because that's where box and whisker diagrams can be quite deceptive, it's indeed this part which is the median, and that's what we want. So all we have to do is read carefully here. So it goes up in ones, so that would be 35, 36. It looks as though we're going to write here 37 for the median. Now it says work out the interquartile range. Now, inter means between. So if you had an intercity train, that would mean it went between cities. Okay, so that's what intercity means, and so interquartile would mean between the quartiles. Now, the main quartiles that we look at in box and whiskers are the lower quartile, do that in red, the lower quartile and the upper quartile. And that distance between them is known as the interquartile range. When you first look at mode, mean, median and range, when you're in primary school, you always look at the lowest part of the data and then you'd look at the highest part of the data. That's called the range. But when you want to look at only 50% of the data, which is what box and whiskers concentrate on, that means you'd have to look between the 25% mark and the 75% mark of the data. And the difference between 25 and 75% is 50%. And that's the interquartile range. So in this situation, we just have to look carefully at the diagram, and let's enlarge this a little bit. So first of all, we want to know where the lower quartile is, so that's here. So that's dead on 35. And then the upper quartile here looks to be at 71. So we've just got to do 71 minus 35, and that will be 36. So we can write that clearly on here. Now the next part of the question is about comparing the two distributions and its quality of written communication again. So you've really got to just look at two things. I always look at two things anyway, and that is I definitely compare the median and I definitely compare the interquartile range. And I write full sentences when I do that. I don't cut any corners there at all. So the first thing that we can notice here is that the median for the winter games, the one with the diagram shown, is clearly 37, and the median here is 121. So I'm going to write the sentence out, and I've written the median number of competitors at the summer games, 121, is greater than the median for the winter games, 37. Although it's really boring having to write such a long sentence out, including the numbers as well, you will definitely get the marks. Okay, so sentences and numbers included. Okay, so let's look at the second part now. So we're going to compare the interquartile range for each set of data. So we're going to firstly look at the interquartile range for the winter games. We've got 36, and if you want to look at the interquartile range for the summer games, we've just got to do 199 minus 83, which is 116, whether you use your calculator or not. So I'm now ready to write my sentence. So I've written the interquartile range for competitors at the Summer Games, 116, is greater than and I put IQR, short for interquartile range, for the Winter Games, 36. So I've compared the medians and what is known as the spread of the data as well. So the spread being the interquartile range.